Assalamualaikum warahmatullahi wabarakatuh. Okay, as you know, we have learned about expert system and then fuzzy logic. Okay, and then for this chapter, you will learn about the artificial neural network. Okay, okay. Before that, okay, let me discuss about the human intelligence versus artificial intelligence. What is the difference between human and artificial? What we human develop it artificial intelligence. What are the difference? Okay, for human intelligence, we look into the human intelligence. Okay, usually, okay, human intelligence can communicate with people. Okay, that's why we say that intelligent. Use available information to take decision, identify pattern in data, remember what people said. Okay, we will remember as a human and adapt to a new situation. Okay, ini human punya intelligent. Okay, how about artificial intelligence? Okay, so AI develop computer system that can accomplish tasks that require human intelligence. Okay, kita cuba adaptkan benda-benda ni semua ke dalam artificial intelligence. Okay, so okay, the computer ataupun robot sini, okay, boleh provide more accurate result. It can interact with human using their natural language, learn from their mistake, okay, and adapt to a new environment, and learn from the data, and automates repetitive learning. Okay, ini yang kita cuba adaptkan human intelligence ke dalam robot as a artificial intelligence. Okay, firstly we look into artificial intelligence. It's the biggest one. Okay, this one the area. Okay, intelligent machine think that intelligent machine that think and act like human being. Ini dia punya idea. Okay, when we talk about artificial learning, we think about the machine can think like human. Okay, first of all, and then in machine learning we have in artificial intelligence we have machine learning. Okay, what is machine learning? Okay, machine learning. Okay, is subset for artificial learning that system learn new thing. Okay, without being programmed to do so. Actually, kalau dalam expert system kita program, human ada program masukkan. And then dalam machine learning, sistem tu yang akan learn sendiri. Okay, dia akan come out, dia akan learn, dia akan train. Okay, so from that training dia akan learn something. Okay, and then dalam machine learning, okay, kita ada deep learning. That means machine think like human brain using artificial neural network. Okay, because human we use brain. Okay, we use neuron and so on. Okay, so it's imitate from that idea how people brain, how human brain, and they produce a method called deep learning. Okay, one of the popular one is the artificial neural network. Okay, because human brain is just like network. Okay, kita ada network. Okay, neuron tu macam network. So that's why it's called neural network. Alright. Okay, kat mana yang nak guna? Biasanya kalau artificial intelligence banyak lah. Okay, and then dekat artificial neural network pun banyak tempat yang kita boleh pakai. Okay, and then sekarang ni pun yang popular is the artificial neural network. Okay, we will use in the handwriting recognition, how to recognize the symbol. Okay, macam dia tulis S. Okay, sebab lain orang, lain penulisan dia. Macam mana sistem nak recognize itu S. Kalau human, kita boleh recognize. Okay, how about the computer? Okay, and then kita ada travel displacement problem, image compression, stock exchange prediction. Okay, dia boleh predict based on the data they get, dia akan cuba predict. Right, and then dalam medicine pun ada image analysis, drug design, diagnosis system, biochemical analysis. Okay, from the data, dia akan train and come up with something, dia akan learn, and then at the last, dia akan make addition based on the system. Okay, make decision based on the problem and so on. Okay, this is what we use this application for the artificial neural network. How the brain works? Okay, dalam brain, human brain, kita ada neuron. Okay, the cell we call neuron. Ini neuron, and then kita ada synapse. Synapse, yang synapse ni ada interconnected so. Okay, dia akan link. Dia ada interconnection between this neuron dengan this neuron. Alright, this called ada synapse. It is 60 trillion connection. Okay, and then for neuron kita ada 10 billion. Banyak 10 billion. Okay, dalam setiap otak manusia. Okay, antara kita guna ke tak, itu lain cerita lah. Alright. Kalau kita guna semua sekali ni, semestly, multiple neuron, okay, we can function, the brain perform its function much faster than fastest computer in existence today. Kalau kita betul-betul utilize, okay, akan lagi cepat daripada komputer. Okay, sekarang kita tak utilize. Okay, hanya dalam berapa persen saja. Okay, tak sampai 10%. Tengoklah. Alright, and then, okay, so dalam neuron, each neuron, okay, dia ada simple structure dia. Dia ada cell body, soma. Okay, cell body, and the number of fiber dendrites and a single long fiber called axon. Okay, setiap neuron ni kita cuba adaptkan dalam bentuk reload this one. Okay, dalam bentuk artificial neural network. Okay, reload. Sebelum tu kita tengok sini dulu. Okay, this one is dendrites. Okay, this one is axon. Okay, ni soma, neuron body dia soma. Okay, dendrit, axon. Okay, we look over here. For soma is a neuron. Soma is a one neuron lah. Okay, and then for the dendrites is the input. Dendrites kan, ini dia punya input. Okay, setiap input. And then axon dia punya output. Ni axon yang paling panjang. Okay, a single long fiber. Okay, this one dia punya output. Apa output dia? From this one, dia punya input, dia masuk sini. Yang weight dia punya synapse. Okay, ni dia punya weight ni, synapse masuk, and then the process ni baru dia keluarkan output. Okay, dalam output axon. Axon lah, keluar kat sini lah dia punya output. Alright. So, artificial neural network is imitated from the human brain. Okay, from the neuron. Okay, I explained previously. Okay, this one. So, like this one, for example. Okay. In neural network, we have input signal. Ini input signal. Setiap input signal dia ada their own weight. Okay, setiap weight dia berbeza. Alright, and then dia akan masuk dalam neuron. Okay, ni big neuron lah. Okay, ni lah body dia. And then dia akan publish dia punya output. Okay, this one dia punya output signal. Right. Okay, this one, neuron use a transfer function to produce and output. Dia ada transfer function Okay, transfer function ni akan produce output from, kita ada weight, signal semua, dia ada satu transfer function. The transfer function tu dijadikan sebagai, sebelum dia akan produce the real punya output, dia akan guna transfer function tu. Like this one, step function, sine function, sigmoid function, and linear function. Right, itu contoh-contoh dia punya transfer function. Okay, kita cuba tengok satu, first one. Okay, the first one, okay, perceptron training algorithm. Okay, step one dia mesti analyze. Okay, analyze the weight. Okay, and then dia punya threshold. Okay, for example, okay, kita tengok set dulu berapa weight dia. This one, weight dia. Okay, what is the weight? And then dia punya threshold. Okay, atau random number. Ini just set any threshold number for negative 0.15. Okay, until 0.15. Okay, and then dia buat, if we go to step 2, that is activation. Okay, dia akan activate the perceptron by activating the input dengan input and desired output, calculate the actual output at iteration p equal to 1. Okay, sekarang ni, okay, for the iteration p equal to 1, yang first dulu dia akan check, okay, dia punya input dengan dia punya weight, dia akan calculate. Okay, dia akan calculate dulu, and then step 3 dia akan weight training. Okay, dia akan update dia punya weight of the perceptron. Okay, dia akan update. Okay, jika ada silap, okay, ada error, dia akan update. Okay, for that iteration. Okay, iteration untuk P. Okay, ini the weight correction compute by data row. Ini dia akan pakai this formula. Right, and then dia akan buat iteration. Okay, increase iteration P by 1, tambah lagi 1. Okay, and go back step 2 and repeat the process until convergence. Okay, maksudnya jika ada error, dia akan repeat balik sampai the meet dia punya sampai dia tak ada error. Okay, sampai output dia nak output apa tu tercapai. Dia akan manipulate dia punya weight tu, modify dia punya weight sampai output output dia tu sama. Okay, selagi ada error, dia akan cuba increase dia punya iteration, repeat back, okay, modify dia punya weight, okay, sampai output dia sama. Right? Ini salah contohnya. Ini dia punya example. Okay, for example for a push 1. Okay, ini dia punya input. Ini desired output. Okay. Maksudnya desired ni memang dia nak produce yang ni sebenarnya. Untuk result ni, dia mesti dapat yang ni. Ini desired. Kalau actual, apa yang dia proses, dia dapat yang tu. Okay. That's mean for just F, for this one, desired dia kosong. Tetapi, bila dia proses, dia dapat 1. That's mean dia ada error lah. Kat situ, tak sama. Apa yang dipredict tu, apa yang sebenarnya tu, data tu tak sama, tak tally. Ada error. Bila ada error, dia akan modify dia punya weight tu lagi. Sampai sama. Sampai dapat result yang sama. Dia akan modify dia punya weight. Alright, that's why kat sini dia punya weight dia lain sikit. Ni kan, ni maintain. Tiba-tiba yang kat sini sebab dapat result lain, dia akan modify. Ni lain sikit Okay, for example untuk this one, ini contoh dia. Okay, for epoch 1, input 1, tengok. Epoch 1, input 1, kosong-kosong. So, dia akan times dengan dia punya weight dia. Tengok, dia akan times, dia akan dapat 0. So, kat sini dia punya threshold dia kita buat 0.2. Okay, threshold dia kita buat 0.2. And learning rate dia, okay, alpha equal to 0.1. Learning rate ni maksudnya bila, maksud learning rate ni maksudnya bila dia nak berubah dia punya weight tu, dia akan menggunakan 0.1. Learning dia. Learning dia macam mana? Weight ni macam 0.3. Okay, bila dia nak modify, contohnya kita akan modifykan nanti kan bila dia ada error. Okay, that means dia akan guna 0.1. Dia akan tolak 0.1 or plus 0.1. Okay, just guna 0.1 punya learning rate. Okay, ini dia punya threshold lah. Okay, for this one tak ada masalah. Okay, bila dia check tengok, kita punya threshold 0.2. So, kat sini kita tengok dia punya 0.2. So, dia lepas lah. Right? 0.2. Okay, akan dapat 0. Okay, so dapat 0 lah. 0, 0. So, tak ada problem lah. So, bila tak ada problem, tak payah modify dia punya weight. Okay, and then kita tengok yang kedua. Yang kedua pun, dia check tengok. Okay, 0. Okay, tak ada masalah. Okay. Tapi, bila dia check yang ketiga, okay, dia dah dapat negative 1. Ada error. Okay. If error is negative, reduce the positive weight. Okay, bila ada dia negatif, error tu negatif, di sini ada error ni, this one negatif, dia akan reduce the positive weight by minus 0.1. So, akan dapat 0.2. Okay, so kat sini kita modify dia. Okay, so dia akan jadi, tengok kat sini, dia akan modify daripada 0.3 tadi, dia tolak 0.1, akan dapat 0.2. Alright. Okay, and then, for then, so, kita akan pakai weight yang baru. Untuk second iteration, kita akan pakai weight yang baru. Okay, untuk input 4, kita pakai 0.2. Kita tengok 0.2 dapat 0.1. And then, lastly, kita dapat 1 pula. Alright. Okay, sorry. Okay, sorry. Okay, 1. Okay, betul. Okay, dapat 1. And then, untuk 1 ni, if positive, include the positive weight. Okay, kita kalau dia error dia positif pula, okay, kita increase dia positive weight. So kita bila nak increase kita kena tambah 0.1. Alright. Okay. And then the training process continue with the same data but different weight since there are some error occur in the first epoch. Okay. First epoch ni, this one dia akan repeat. Okay, kalau ada error dia akan continue to repeat. Okay, this one learning rate 0.5. That's mean if learning rate 0.5, nanti dia when it want to modify the weight must plus 0.5 or minus 0.5. Okay, ini dia punya learning rate. Okay. And then for activation function, okay, activation function dia is sum more than 4, output is 1 and else output is 0. Okay. Ini dia nak determine dia punya output. Okay, berdasarkan dia punya activation function this one. Okay, and then kita ada two training data. Okay, for input 1, 1, the output must be 1. Okay, and then the other input is 0, 0, the output must be 0. Okay, macam mana kita nak buat? For the input 1, 1. For example, input 1, 1. Okay, for example 1, 1 ni x1, 1 lah. And then for this one, for example, kita nak dapat yang 3. Berapa value yang 3? Okay, note yang ketiga, we need to multiply dia punya input dengan dia punya weight. For example, N3, kita nak dapatkan note yang 3. Okay, output is 1. So 1 times dengan dia punya weight. Input 1 times dengan 1. And then for 2, dia punya weight dia 2. So dia punya input dia 1. Okay, 1 times dengan 2. Okay, 1 times dengan 1. 1 times dengan 2. So dapat 3. So kita tengok dia punya activation function dia must be less than 4. Jika dia less than 4, okay, less than 4, the output is 0. So kita dapat, and node untuk 3 ialah 0. Kat sini jadi 0. Okay, and then kita tengok node 4. Okay, input dia still sama. 1, 1. Okay, tapi dia punya weight dia 2, sini 2, sini 1. Kita tengok sini. 2, 1, weight dia. And then dia punya input dia still sama, 1, 1. So kita akan dapat 3. Dia punya output. Okay, dia punya summation lah. Okay, and then sum less than 4, betul. Less than 4. Okay, 3 less than 4. So, bila guna activation function, dia 0. So, and then kita akan dapat node 3 dengan 4 ialah 0. Sini 0, sini 0. So, untuk check yang 5, ini dia punya weight. Okay, kita cuba times, tengok. Times, tengok, and then 2, 0 times 2, 0 times 1. So, akan dapat 0. Is it the 0 less than 5, less than 4? Okay, and then smaller than 4. Okay, and then n equal to 0. Okay, kita tengok sini activation function dia, sebab dia dapat, kita dapat 0. So bila dia dapat 0, dia akan dapat output dia 0. Okay, tetapi okay, we look over here. Okay, kat sini dibagi dia punya desired output dia 1. Tetapi yang kita dapat 0. N5 ni, ini dia punya output lah. Ini kita dapat 0. Should be salah lah. Apa yang kita desire, apa yang kita predict awal-awal tu, yang kita memang itu jawapan dia. Okay, is that result. Tapi kita time kita kira dapat lain. Okay, so that's mean benda tu salah. Kan? That's wrong. Okay, yang kita cara pengiraan tu silap. Bila salah, okay, dia akan adjust dia punya weight by 0.5. Ini dia punya learning rate. Okay, 0.5. So dia akan plus 0.5. Okay, jika kita dapat positif, okay, so dia akan add. Okay, jika value error dia positif, kita akan add negative positive value. Kita tambah 0.5. So untuk 1 kita akan jadi 1.5, tu akan jadi 2.5. Okay, bila dia adjust. Okay, so the inputs yang kedua, the second input. Okay, second inputs dia akan pakai yang baru punya weight. Okay, kita tengok yang baru punya weight. This one 0, 0. Okay, so dia akan pakai 0, 0. Okay, so akan dapat 0 less than 4. And then N4 pun dia akan pakai 0, 0. 1.5, 2.5 dia punya weight dia, weight yang baru. Okay, akan dapat 0. N3 and not 3 and 4 akan dapat 0 sama 0 0. And then dekat sini pun dekat N4 N5 pun dia akan kira ini 0 ni 0, dia akan count, dia akan dapat 0. Okay, so dia check kat sini last kali sebab ni input yang kedua. Okay, output dia 0. So betul, that's correct. Okay, bila correct, no adjustment to the weight. Okay, bila betul, tak ada adjustment. Tapi bila ada salah, dia akan adjust dia punya weight sampai dia meet dia punya weight yang betul-betul desired, atau yang betul-betul tepat. Okay, untuk dapat result yang betul. Right? Okay, how does AN learn? Okay, macam mana dia belajar? So dia akan make semua adjustment, adjust dia punya weight, edit dia punya weight to reduce the difference between actual and desired output. Okay, dia akan cuba loop, tengok, buat iteration sampai dia meet dia punya desired. Okay, desired output. Okay, mesti sama. Okay, macam itulah dia akan learn. Okay, ini example training of neural network. Okay, nampak lagi view dia. Ini dia punya view, dia punya input 1.4, 2.7, 1.9. Okay, ini dia punya class. That means dia akan produce dia punya output lah. This one 0, 0, ni 1, ni 0. Okay, untuk this data. Alright, so far, okay, kita training data, ni dia punya training data, present the training pattern. Okay, 1.4, 2.7, 1.9. Okay, ini dia punya input. Okay, and then Go next. Kemudian feed the through the to get output by multiplying the weight random weight. Kita ada kat sini, dia akan ada weight and then dia akan multiply. Okay, 1.4, 2.7 and 1.9 dia ada multiply with the weight and then compare with the target output. Okay, for example, okay, this one dia dapat 1. Kat sini compare with target output, tiba-tiba kat sini kelas dia 0, should be 0, tapi dia dapat 1. Okay, bila dapat 1, so dia akan adjust dia punya weight. Okay, should be kan dapat 0. Kan kat sini kita dah mention kat 0. Ini dia punya, should be dia punya output. Okay, macam kita tengok gambar lah, gambar. Okay, gambar, data dia, cakap gambar tu, berdasarkan data apa semua, okay, gambar tu ialah kucing. Tapi last sekali, dia detect gambar tu ialah kuda. So, lain lah. So, kita kena ketuk dia punya weight tu. Ketuk dia punya weight. Okay, modify dia punya weight. Okay, and then, okay, repeat with 1000 times. Kita akan repeat lagi. Kita akan repeat lagi data. Okay, repeat buat lain. Adjust dia punya weight. Sampailah dia dapat. The result is 0. Okay, dia akan adjust. Okay, macam tu lah dia punya learn. Okay, dia modify dia punya weight tu. Right? Okay, what is the purpose of the training process? Okay, apa sebenarnya bila kita train tu, apa dia punya purpose? The purpose is, okay, kita nak save dia punya final weight. Final weight ni sebenarnya dia punya model. Okay, model tu, dia punya network, okay, weight dia tu, bila dapat weight tu, itu dia sebenarnya tu kita buat training tu. Okay, training akan produce dia punya model. Dalam model tu ada weight. Right? Okay, so is it N is a classifier? Okay, first of all, what is classifier? That mean classifier, it can determine, it can classify. Okay, this object with this object, classify this cluster with this cluster. Okay, categorize. Okay, itu classifier. Is it ANN can be a classifier? Okay, the answer is yes. Okay, bila dia learn something, okay, bila learn, it can classify something. Okay, it can make decision to classify, to cluster, and to categorize something. Right? What it have learned. Okay, for example, like this one. Okay, ini dia punya input lah. Input that means dia punya feature. Dia input come from the feature. Sebab kita nak buat classification. Okay, for example, this one untuk color. Okay, feature dia texture. Sini texture. And then dia punya shape. Okay, ini dia punya feature lah. Feature ni kita akan train. Okay, and then lastly kita will use the model to classify something. Right? Kita tengok over here. For example, this one. Before that, for example, this one kita ada NNN, additional network, SVM, KNN, okay, ada beza This one KNN, ini methods lah. Methods dalam neural network. Dalam neural network pun dia ada methods dia. Okay, sebab it will improve the methods. Neural network is just like general. Okay, general method. So, mungkin setelah research dia akan enhance lagi. Dia akan add a new thing, add a new layer and so on. So, dia akan produce term yang lain. Okay, tapi dia punya basic dia neural network lah. NN, KNN and so on. Okay, so we look over here for this one. Ini ada test cuba buat. This one ripeness classification of palm oil fresh fruits bunch. Kelapa sawit kita nak tengok dia dah masak ke belum. Okay, dia train guna 160 images. Okay, sikit je lah, tak ada banyak sangat tak sampai ribu-ribu. Okay, and then dia cuba test juga guna classifier SVM. Okay, SVM and then kalau guna KNN. Okay, ini dia punya features. Okay, tapi what this one dia just test just one features je lah. Okay, RGB color moment. Satu features je, RGB color moment dapat 985. Kalau HOG, okay, akan dapat 0.65. Dan kalau RGB color moment, okay, sama, feature sama, tapi dia punya classifier yang lain, methods yang lain, okay, akan dapat 0.94. Okay, dia ada increasing. Dia ada banyak, lebih sikit lah. Ini dia punya method lah, method. Okay, dia sebenarnya neural network is better than SVM. Alright. Ini vector machine ni. Okay, what is the advantages and the disadvantage of artificial neural network? Okay, advantage dia. Okay, neural network can perform tasks in which a linear program can perform. Okay, ini dia punya advantage. Okay, linear program ni macam dia rigid punya decision lah. Okay, sebab ANN dia boleh learn, cuba train and learn a new thing. Okay, cuba and then cuba repair, repair dia punya weight. Okay, untuk get the desired output. Okay, ni advantage dia. Okay, untuk NNN. And then for the advantage, it require training to operate. Memang kena training. Okay, ada banyak data untuk training. Kalau sikit data, mungkin dia not perform the best. But it really need to training with large data set. Okay, for the best performance. Okay, ini dia punya advantage lah. This mean you all kena collect data yang banyak. Okay, and then suruh dia buat training. What influence the performance of an ANN? Apa yang influence the performance? Okay, macam mana kita nak determine yang program yang kita buat pakai ANN tu bagus. Okay, based on what? Okay, the first of all, based on the size of training data. Okay, jika you training 50, 30, 20, memang result dia, it depend, but memang takkan dapat yang betul-betul yang baguslah result dia. Okay, mungkin ada error and so on. Okay, and then the second one is architecture of the network. Okay, macam mana architecture dia? Sebab NNN ni macam banyak architecture, banyak hidden layer and so on. Architecture apa yang you all pakai. And then ada complexity of the problem. Okay, problem tu macam mana? Okay, problem yang you nak solve tu kompleks ke tidak? Okay, kalau benda tu kompleks, okay, tapi you pakai NNN yang biasa, okay, mungkin performance dia low sikit lah. Tengoklah complexity of the problem. Okay, first of all, kita tengok dulu first training data set is one. Macam mana kita nak tentukan dia punya training data set. Okay, and then you must determine N ni dia punya total lah. Berapa data set you nak. And W ni dia punya weight. How many weight nodes, total number of weight must be times dengan network error permitted for the testing phase. Contohnya, you kata error mungkin dalam 10%. Kita nak kata dalam 10%. Okay, so dalam 10%, so must, for example, you all punya node ialah 10, 10, divide by 0.1, so you can 100. So the total training set, training data must be 100. Okay, ini bagus lah, that's mean okay lah. Okay, based on this one. Okay, node pun you ada 10 je. Right. Okay, how do we massage data? Okay, macam mana kita, because our data sometimes dot zero can be divided into 2, 3 first. Okay, it can be discrete, continuous, discrete and categorical. Okay, our data must be between 0 and 1. Okay, first of all, our data input must be 0 and 1. Tak ada you put 100, okay, 50, 1000, itu not accepted. Okay, must be 0 and 1. Right? And then, okay, must be ni, this one. Okay, because ANN work best when all input and output vary within the range 0 and 1. Okay. All data, I mentioned before, it can be using ANN model. Okay, memang best in 0 and 1. Okay, you need to normalize first. Okay, and standardize it. And then, okay, we have continuous. For continuous data, okay, to make it between 0 and 1, you use this function, this equation. Okay, actual value minus by minimum value. Okay, and then kita divide by maximum value minus minimum value. So, akan dapat 0 point something. Okay, dalam hexadecimal lah. Alright. Okay, so it will become, it will between 0 and 1. Okay. And then for example like this one untuk discrete data. Okay, senang lah nombor backroom jika 1, 0. Okay, bila 2, 0.25, 3, 0.5, 4, 0.75. Right, ini depend. Ini discrete. Okay, so dia punya message value. Okay, massage value dia, massage value 0 until 1. So, ini dia punya massage value. Okay, for categorical, for example like this one, okay, because it will need 0 and 1 or between. Okay, for example macam categorical, macam single, married, divorce and widow. Okay, kita boleh buat macam ni, this one. So, kalau dia widow, Okay, so kita tick 1 lah. Okay, yang ada others kita akan put 0. Okay, for example kalau dia divorce put 1, jika dia married put 1, yang lain ni kita put 0. Alright, ini macam mana kita nak massage dia punya data. Okay, supaya bila masuk tu model tu mudah understand. Memang senang faham lah, senang dia nak learn something from that data. Okay, dia boleh baca pattern dia. Okay, this why kita kena clear dulu. Okay, dia punya data tu. Okay, make a standard. Okay, and normalize. Okay, as a conclusion, okay, NNN is good to apply in many of the application, in business, in the medicine, okay, in the industrial, and so on. Okay, and then dalam NNN pun ada banyak types. Contohnya ANNN, KNN, okay, method dia lain sikit lah. Okay, basic dia sama tapi method dia lain sikit. Okay, chemical and so on. Okay, and then okay, and then you can apply into classification, clustering, okay, recognitions, okay, semua boleh pakai, can be used in neural network. Okay, you can test. Okay, and the features pun you boleh combine. Okay, how many features and combine fusion between diffusion and diffusion and so on. Okay, and try the best to get the best accuracy result. Right, I think.